Hello there, and welcome. Tonight I want to take you somewhere special, somewhere that exists at the intersection of mystery and wonder, where the boundaries between what we know and what we can only imagine blur into something beautiful and profound. Settle in, make yourself comfortable, and let me share with you a story that begins on a warm August night in 1977, but perhaps, just perhaps, stretches back through billions of years of cosmic time. You see, we're going to explore a question that might initially seem too extraordinary to consider seriously. But as we journey together through the vast expanses of space and time, you might find yourself wondering if the most extraordinary possibility is actually the most likely one. What if the famous WOW signal, that enigmatic 72-second radio transmission from deep space, wasn't an ending or an isolated incident, but rather the very beginning of something far more profound than we've ever dared to imagine? Before we dive into the depths of this cosmic mystery, I want you to know that wherever you're watching from right now, whether it's late at night in New York, early morning in Tokyo, or somewhere in between, you're part of this exploration. Take a moment to tell us in the comments where you're tuning in from and what time it is there. It's fascinating to think that people all around our small blue planet are contemplating these vast cosmic questions together, united by our shared curiosity about what lies beyond. And if you find yourself drawn into this journey, if these mysteries speak to something deep within you, consider subscribing to join us for more explorations into the wonders of our universe. Give this video a like if it resonates with you, as it helps others discover these peaceful journeys through space and time. But for now, let's return to that August night when everything might have changed. Picture, if you will, the Big Ear radio telescope in Ohio, standing like a patient sentinel against the night sky, its massive structure quietly listening to the cosmos. This wasn't a telescope in the traditional sense that you might imagine, with lenses and mirrors designed to capture light from distant stars. No, the Big Ear was something different. Something perhaps more intimate in its connection to the universe. It was designed to hear rather than see, to detect the faint radio whispers that travel across the incomprehensible distances between stars. On this particular night, August 15th, 1977, the telescope was performing its usual patient vigil, methodically scanning the heavens as part of the search for extraterrestrial intelligence, or SETI. The computer systems were recording data automatically, converting the radio signals from space into numbers and patterns that could later be analysed by human eyes and minds. The universe speaks to us constantly in radio waves, you see. Every star, every planet with a magnetic field, every swirling galaxy produces these electromagnetic whispers that travel at the speed of light across the cosmic void. Most of these signals are what we call natural phenomena, the background static of a universe in constant motion and transformation. Stars are born in spectacular clouds of gas and dust, sending out powerful radio emissions as they ignite their nuclear furnaces. Pulsars, those impossibly dense remnants of dead stars, spin like cosmic lighthouses, sweeping beams of radio energy across space with clockwork precision. Black holes, those mysterious gravitational monsters, create intense radio emissions as they devour matter, converting the death screams of falling gas and dust into electromagnetic radiation that can travel for billions of years before reaching our small planet. But on this night, something different happened. Among all the cosmic noise, all the natural radio chatter of the universe, The big ear detected something that would make a scientist named Jerry Eamon write a single word that would echo through history. When Eamon reviewed the computer printout days later, he saw a signal so unusual, so perfectly structured, so unlike anything they ever detected before, that he circled it with red pen and wrote "wow" in the margin. This simple, human expression of astonishment would give the signal its name and launch thousands of investigations, theories, and dreams about what it might mean. The signal itself was remarkable for several reasons, each one adding another layer to the mystery that continues to captivate us nearly half a century later. First, there was its intensity. The wow signal was strong, about 30 times more powerful than the background radiation of deep space. Imagine standing in a quiet library where everyone is whispering, and suddenly hearing someone speak in a clear, normal voice. That's the kind of distinction we're talking about, a signal that stood out dramatically from the cosmic background noise that the big ear had been patiently recording for years. This wasn't a faint whisper that required careful analysis to detect. It was a clear, unmistakable transmission that announced itself boldly against the quiet hum of the universe. Then there was its frequency, 1420 megahertz, which adds another fascinating dimension to our mystery. This particular frequency isn't random. It's special in a way that suggests either an incredible cosmic coincidence or perhaps something more intentional. You see, 1420 megahertz is the natural emission frequency of hydrogen, the most abundant element in the universe. When hydrogen atoms undergo a specific energy transition, they emit radio waves at exactly this frequency. It's like a universal calling card, a frequency that any civilization with knowledge of basic physics would recognize as significant. Scientists have long speculated that if an intelligent civilization wanted to send a message that other intelligent beings would notice, they might choose this frequency precisely because it's so fundamental to the physics of our universe. Consider for a moment the implications of this choice. If you wanted to send a message to someone you'd never met, someone whose language you didn't speak, whose culture you couldn't understand, how would you do it? You might start with something universal, something that transcends the barriers of different evolutionary paths and cultural developments. Mathematics and physics are the same everywhere in the universe. The ratio of a circle's circumference to its diameter is pi, whether you're on Earth, orbiting Alpha Centauri, or in a galaxy billions of light years away. Similarly, hydrogen behaves the same way throughout the cosmos, making its emission frequency a kind of universal standard that any technologically capable civilization would know. The duration of the signal, those 72 seconds that have become so famous in the annals of SETI research, tells us something important about its origin. The Big Ear telescope was designed to use the rotation of the Earth itself as its scanning mechanism. As our planet turned, the telescope's field of view would sweep across different parts of the sky. Any distant radio source, whether it's a star, a galaxy, or perhaps something more exotic, would appear in the telescope's view, grow stronger as it passed through the center of the observation window, and then fade as the Earth's rotation carried it out of view. This process, for a source at a fixed position in space, would take exactly 72 seconds. The wow signal followed this pattern perfectly, rising and falling in intensity exactly as you would expect from a distant stationary source. This characteristic rise and fall tells us that whatever produced the wow signal, it wasn't moving relative to the stars. It wasn't an aircraft flying overhead, it wasn't a satellite orbiting Earth, and it wasn't some form of terrestrial interference. The signal came from a fixed point in the constellation Sagittarius, a region of space that lies in the direction of our galaxy's centre, where stars cluster more densely than in our local neighbourhood. When we look toward Sagittarius, we're looking into the heart of the Milky Way, toward regions where billions of stars swirl in an ancient cosmic dance, each one potentially harbouring planets, moons, and perhaps, just perhaps, other beings looking out at their night sky and wondering if they're alone. But here's where our mystery deepens even further. Despite numerous attempts to detect the signal again, despite pointing every available radio telescope at the same patch of sky, despite years of patient listening, the wow signal has never repeated. It appeared once for those 72 seconds in 1977 and then vanished as completely as if it had never existed at all. This absence of repetition has puzzled scientists for decades. Natural astronomical phenomena typically repeat. Pulsars pulse regularly, quasars emit continuously, and even the most variable cosmic radio sources show patterns over time. But the wow signal appeared once and only once, like a cosmic flash of lightning that illuminated something profound before returning us to darkness. Some have suggested that this lack of repetition actually makes the signal more interesting, not less. Think about it from the perspective of a civilization trying to announce its presence to the cosmos. Broadcasting continuously would require enormous amounts of energy that even an advanced civilization might not want to dedicate to what amounts to a cosmic shot in the dark. But what if instead they sent out periodic beacons, sweeping the sky with directed transmissions, knowing that the odds of anyone being in the right place at the right time to receive them would be astronomically small? We might have been extraordinarily lucky to catch one of these beacons during the brief window when it was pointed at our small corner of the galaxy. Or perhaps the signal wasn't meant for us at all. Consider the possibility that we intercepted communication between two distant points, like accidentally overhearing a conversation in a language we don't understand. The universe could be filled with such communications, narrow beam transmissions between worlds, between spacecraft, between outposts of civilizations that have spread across the stars. We happened to be in the path of one of these beams for 72 seconds in 1977, eavesdropping on a cosmic conversation whose participants will never know. There's something deeply humbling about this possibility, isn't there? It reminds us that if the universe is indeed populated with other intelligent beings, we might not be central to their concerns or even aware of their existence. They might be going about their lives, their explorations, their own searches for meaning and connection, without any knowledge that on a small blue planet orbiting an ordinary yellow star, a species has just recently developed the ability to listen to the radio whispers of the cosmos. We might be like children who have just learned to read, discovering that the world is full of books written in languages we're only beginning to recognize as languages at all. The location of the signal's origin adds another layer of intrigue to our contemplation. The constellation Sagittarius, where the wow signal originated, is rich with stellar neighborhoods that could potentially harbor life. There are old, stable stars that have been shining steadily for billions of years, providing the kind of long-term energy source that life might need to evolve and develop technology. There are also younger stars, perhaps surrounded by planets in the early stages of their development, worlds where the chemistry of life might just be beginning its long journey toward complexity and consciousness. When we point our telescopes toward this region of space, we see a tapestry of stellar evolution on display. There are red giants, massive stars in the final stages of their lives, swollen to enormous size as they exhaust their nuclear fuel. There are white dwarfs, the compressed cores of dead stars, slowly cooling over billions of years like cosmic embers. There are binary systems where two stars orbit around their common center of mass, creating complex gravitational environments that might produce unique conditions for any planets in their vicinity. Each of these stellar systems has its own story, its own history stretching back billions of years, its own potential for harboring worlds we can barely imagine. The distance to the source of the wow signal remains unknown, adding yet another dimension to our mystery. Radio waves travel at the speed of light, but they don't come with timestamps telling us when they began their journey. The signal could have originated from a star system relatively close to us, perhaps only a few dozen light years away, meaning it was transmitted when disco was popular on Earth in the 1970s. Or it could have come from much farther away, perhaps thousands of light years distant, meaning it was sent when human civilization was just beginning to develop agriculture, or even earlier, when our ancestors were still learning to use tools. This uncertainty about distance connects us to one of the most profound aspects of astronomy and cosmology. When we look out into space, we're also looking back in time. The light and radio waves we receive from distant objects show us not how they are now, but how they were when that radiation began its journey. If the wow signal came from a civilization 1,000 light years away, then we detected a transmission that was sent 1,000 years ago. The beings who sent it, if indeed it was sent by beings at all, might have developed unimaginably advanced technology in the intervening millennium, or they might have disappeared entirely, their civilization rising and falling in the time it took their signal to reach us. This temporal displacement adds a poignant quality to our search for extraterrestrial intelligence. We're not just separated from potential cosmic neighbours by vast distances of space, we're also separated by vast gulfs of time. Even if we detected a signal today and immediately sent a response, that response would take years, decades, centuries, or even millennia to reach its destination. By the time it arrived, the civilization that sent the original signal might have changed beyond recognition. This is assuming, of course, that civilizations even operate on timescales comparable to our own. Perhaps there are forms of intelligence that think and act on timescales we can barely comprehend, for whom 1,000 years is but a moment, or conversely, for whom a single Earth day contains eons of experience and thought. But let's return to that August night in 1977 and consider what was happening on Earth at that moment. It was a time of remarkable human achievement and exploration. Just a few years earlier, humans had walked on the moon, leaving footprints in lunar dust that will last for millions of years. The Voyager spacecraft were being prepared for launch, destined to carry golden records containing the sounds and images of Earth into interstellar space. The first personal computers were beginning to appear, harbingers of a digital revolution that would transform human civilization. And in Ohio, a radio telescope was quietly listening to the cosmos, part of humanity's first serious attempt to detect signals from other intelligences. There is something beautifully synchronistic about the timing of the wow signal. It arrived just as humanity was taking its first tentative steps toward becoming a spacefaring civilization, Just as we were beginning to understand our place in the cosmos not through mythology or philosophy alone, but through direct exploration and scientific observation. It's as if the universe chose that moment to whisper to us, to give us a hint that we might not be alone, that the vast cosmic darkness might be populated with other minds, other dreams, other beings looking up at their night skies and wondering about their place in the grand scheme of existence. The scientific community's response to the wow signal has been fascinating to observe over the decades. Initially, there was excitement tempered with appropriate skepticism. Scientists understand that extraordinary claims require extraordinary evidence, and a single, unrepeated signal, no matter how intriguing, doesn't constitute proof of extraterrestrial intelligence. Numerous hypotheses have been proposed to explain the signal through natural phenomena or human-made interference. Some suggested it might have been a reflection of a terrestrial signal off a piece of space debris. Others proposed it could have been a previously unknown natural astronomical phenomenon. Still others wondered if it might have been a classified military transmission that accidentally leaked into the Big Ear's receivers. Yet despite decades of investigation, none of these explanations has proven entirely satisfactory. The signal's characteristics don't quite match any known natural phenomenon. Its frequency and intensity profile don't align with what we'd expect from terrestrial interference. The more scientists have studied the wow signal, the more it has resisted easy explanation, maintaining its status as one of the most intriguing mysteries in the search for extraterrestrial intelligence. It remains a question mark written in the margins of our understanding, a reminder that the universe still holds secrets we haven't even begun to uncover. What strikes me most about the wow signal is not just its scientific significance, but its cultural and philosophical impact. It has become a symbol of possibility, a reminder that we live in a universe where surprises are still possible, where a routine night of observation can suddenly become historic. It represents the moment when an abstract possibility that we might detect signals from another civilization became a concrete reality that demanded explanation. Even if the signal ultimately proves to have a natural or terrestrial origin, it has already succeeded in expanding our imagination about what might be possible. The signal has inspired countless scientific papers, books, documentaries, and works of fiction. It has motivated new searches, new technologies, and new ways of thinking about the search for extraterrestrial intelligence. It has become part of our collective mythology, a modern equivalent of ancient stories about messages from the gods or signs in the heavens. But unlike those ancient myths, the wow signal is grounded in scientific observation, in data that anyone can examine, in a mystery that invites investigation rather than demanding faith. As we contemplate the wow signal nearly half a century after its detection, we find ourselves in a dramatically different world. Our technology has advanced in ways that would have seemed like magic to the scientists of 1977. We have space telescopes that can detect planets orbiting distant stars, radio telescopes that can survey vast swathes of the sky simultaneously, and computer systems that can analyze data in real time, searching for patterns that human observers might miss. We've discovered that planets are common throughout the galaxy, that many stars host entire systems of worlds, some of which orbit in the habitable zones where liquid water could exist on their surfaces. These discoveries have transformed the context in which we interpret the wow signal. In 1977, We didn't know for certain that other stars had planets. Now we know that planetary systems are the rule rather than the exception. We've detected thousands of exoplanets, and statistical analyses suggest that there are billions more in our galaxy alone. Some of these worlds are Earth-like in size and temperature. Some orbit stars that are older and more stable than our Sun. Some exist in binary or multiple star systems that create exotic environments we're only beginning to understand. Each of these worlds represents a roll of the cosmic dice, a chance for chemistry to become biology, for biology to become intelligence, for intelligence to become technology, capable of sending signals across the vast distances between stars. The wow. Signal also raises profound questions about the nature of intelligence and communication. If it was indeed a signal from another civilization, what were they trying to say? Was it a beacon, simply announcing, "We are here"? Was it a message encoded with information about their world, their biology, their culture? Or was it something else entirely? A type of communication we don't yet have the conceptual framework to understand? We tend to imagine that extraterrestrial intelligence would think and communicate in ways similar to our own, but this might be a failure of imagination on our part. Intelligence that evolved independently on another world, under different conditions, with different sensory capabilities and different evolutionary pressures, might have developed forms of thought and communication that we can barely conceive. Consider the diversity of intelligence on Earth alone. Dolphins use echolocation to create three-dimensional sonic maps of their environment. Octopi can communicate through rapid changes in skin color and pattern. Some birds navigate using quantum entanglement in special proteins in their eyes. Bees dance to convey complex information about the location of food sources. If intelligence on Earth has taken such varied forms, how much more varied might it be on worlds with different chemistries, different gravities, different day-night cycles, different evolutionary histories? The wow! Signal might have been our first glimpse of a kind of intelligence so different from our own that we can't yet recognize it as communication. Perhaps what we interpreted as a simple narrow-band radio signal was actually something far more complex, layered with information in ways we don't yet know how to decode. Perhaps the 72-second duration wasn't arbitrary, but meaningful in ways we haven't discovered. Perhaps the choice of frequency, the specific intensity pattern, the precise timing, all contained information that we're not yet sophisticated enough to extract. Or perhaps, and this is a possibility that fills me with a particular kind of wonder, the signal itself was less important than the effect it would have on any civilization that detected it. Perhaps advanced civilizations seed the galaxy with signals designed not to convey specific information, but to spark curiosity, to encourage younger civilizations to develop their own capabilities, to join a cosmic community of minds that have learned to listen to the universe. The wow! Signal, in this interpretation, succeeded perfectly. It made us wonder. It made us search. It made us imagine possibilities beyond our previous conceptions. As we lie here contemplating these possibilities, it's worth reflecting on how the search for extraterrestrial intelligence has changed us as a species. Before we started listening to the cosmos, we could imagine that Earth might be unique, that life might be a cosmic accident that occurred only once in the history of the universe. But now, having detected that enigmatic signal, having discovered planets throughout the galaxy, having understood the chemical and physical processes that lead to life, we can no longer maintain that provincial view. We know that the universe is vast beyond comprehension, that it contains billions of galaxies, each with billions of stars, many with planets, some of which surely harbour the conditions for life. The wow. Signal represents a threshold moment in human consciousness, the moment when we realise that we might not be alone, that the universe might be populated with other minds contemplating their own existence, sending out their own signals, conducting their own searches for cosmic companionship. Even if we never determine the true origin of the signal, even if it remains forever a mystery, it has already changed us. It has made us a species that looks outward, that listens to the cosmos, that imagines ourselves as part of a larger community of intelligence that might span the galaxy or even the universe. And perhaps that's the most important legacy of the wow. Signal. Not what it was, but what it represents. It represents our transition from a species trapped on a single world to one that has begun to engage with the cosmos. It represents our growing maturity as a technological civilization, our ability to detect and contemplate phenomena that originate far beyond our planet. It represents hope, hope that we're not alone, hope that intelligence is a common outcome of cosmic evolution, hope that someday we might join a galactic community of minds that have transcended the boundaries of their birth worlds. But what if, and here's the thought that we'll explore throughout our journey tonight, what if the wow signal wasn't unique? What if it was simply the first of many signals that we've detected but not recognized? What if the universe is actually filled with such transmissions, and we've only just begun to develop the ability to detect them? What if the wow signal was not an isolated incident, but the beginning of a new chapter in human history? The chapter where we discover that the cosmos is alive with intelligence, with communication, with beings trying to reach across the vast distances that separate us. This possibility transforms the wow signal from a historical curiosity into something far more significant. The first note in a cosmic symphony that we're only just learning to hear. Perhaps in the years since 1977, we've detected other signals without recognizing them. Perhaps our instruments have recorded transmissions that we've dismissed as interference or natural phenomena. Perhaps the universe has been trying to tell us something, and we're still learning the language in which it speaks. Imagine Earth as a small island in an infinite ocean, an ocean not of water but of space and time, stretching endlessly in all directions. For most of human history we've been confined to this island, able to look out at the vast expanse surrounding us, but unable to venture far from our shores, or even to know if other islands existed in that cosmic sea. But in the middle of the 20th century, something remarkable happened. We began building lighthouses, not to warn ships away from our shores, but to search the darkness for signs that we're not alone. These lighthouses are our radio telescopes, and they represent one of humanity's most ambitious and hopeful endeavours, the systematic search for intelligence beyond Earth, the Big Ear. Telescope that detected the wow signal was one of these cosmic lighthouses, but to understand its significance we need to understand the remarkable story of how humanity learned to listen to the universe. It's a story that begins not with telescopes or technology, but with a simple realization that would transform our understanding of our place in the cosmos. In the early 20th century, scientists discovered that the universe was speaking to us in a language we'd never noticed before, the language of radio waves. These invisible electromagnetic waves, the same ones that carry music to our radios and data to our phones, were also streaming in from space, carrying information about distant stars, galaxies, and perhaps other civilizations. The discovery of cosmic radio waves was entirely accidental, as many of the greatest scientific discoveries are. In 1932, a young engineer named Karl Jansky was working for Bell Telephone Laboratories, trying to identify sources of static that were interfering with transatlantic radio communications. He built a large antenna, 30 meters long and 6 meters tall, mounted on wheels from a Model T Ford so it could rotate. His colleagues called it Jansky's merry-go-round, but this ungainly contraption would open an entirely new window on the universe. As Jansky methodically tracked down sources of radio interference, he noticed something peculiar. There was a persistent hiss that seemed to come from a specific direction in space, a direction that changed throughout the day as Earth rotated. At first, Jansky thought this cosmic static might be coming from the sun, but careful observation revealed something even more remarkable. The signal was coming from the direction of the constellation Sagittarius, the same region of sky where, 45 years later, the WOW signal would originate. Jansky had discovered that the center of our galaxy was a powerful source of radio waves, that the Milky Way itself was broadcasting across the electromagnetic spectrum. This discovery was revolutionary. It meant that the universe was filled with information traveling in forms our eyes couldn't see, that there were entire dimensions of cosmic activity invisible to traditional optical telescopes. Think about the implications of this discovery for a moment. For all of human history, we had been studying the universe using only the narrow slice of the electromagnetic spectrum that our eyes can detect. It was as if we'd been listening to a symphony, but could only hear the notes from a single instrument. Suddenly, Jansky had revealed that the cosmos was performing a far richer, more complex composition, with frequencies ranging from the deepest bass to the highest treble, most of which we'd been completely deaf to. The universe wasn't silent, we just hadn't known how to listen. The development of radio astronomy following Jansky's discovery was slow at first, interrupted by World War II and limited by technology. But in the post-war years, scientists and engineers who had developed radar and other radio technologies for military purposes turned their attention to the stars. They began building increasingly sophisticated radio telescopes, each one capable of detecting fainter signals from farther away, each one adding new capabilities to our cosmic listening posts. These instruments were unlike traditional telescopes in almost every way. Instead of mirrors and lenses designed to focus light, they used massive dishes or arrays of antennas to collect and focus radio waves. Instead of producing images that could be directly observed, they generated data, streams of numbers representing the intensity of radio emissions from different parts of the sky. The Big Ear telescope, constructed at Ohio State University in the 1960s, represented a unique approach to radio astronomy. Unlike the massive dish antennas being built elsewhere, the Big Ear used a design called a Krauss-type telescope, named after its inventor, John Krauss. Picture two massive metal reflectors, each the size of a football field, arranged to focus radio waves onto a series of receivers. The telescope couldn't be pointed at specific targets. Instead, it relied on Earth's rotation to sweep its field of view across the sky. This design made it perfect for survey work, for patiently monitoring large swaths of the heavens, waiting for something interesting to appear. The Big Ear was specifically designed with SETI in mind, the search for extraterrestrial intelligence. This might seem like science fiction, but by the 1960s, serious scientists had begun to consider the possibility that radio waves might be the perfect medium for interstellar communication. Radio waves travel at the speed of light. They can penetrate the gas and dust that fills interstellar space, and they require relatively little energy to generate compared to other forms of electromagnetic radiation. If an alien civilization wanted to announce its presence or communicate across interstellar distances, radio waves would be a logical choice. But where should we listen? The radio spectrum is vast, stretching from extremely low frequencies measured in hertz to extremely high frequencies measured in hundreds of gigahertz. Searching the entire radio spectrum would be like trying to find a specific conversation in a city where millions of people are talking simultaneously on millions of different channels. Scientists needed to make educated guesses about which frequencies an alien civilization might choose for their transmissions. This led to the concept of the waterhole, a quiet region of the radio spectrum between 1420 MHz and 1662 MHz. The lower boundary is the emission frequency of hydrogen, the most abundant element in the universe. The upper boundary is the emission frequency of hydroxyl O. Together, H and OH make H2O, water, the substance essential to life as we know it. The poetic beauty of this choice shouldn't be lost on us. Just as animals on Earth gather at waterholes to drink and socialize, perhaps intelligent civilizations would gather at this cosmic waterhole in the radio spectrum to communicate. It's a frequency range that any technologically advanced civilization would know about, a universal meeting place determined by the fundamental physics of the universe rather than by arbitrary choice. When the wow signal appeared at 1420 MHz, right at the hydrogen line, it seemed to confirm that if extraterrestrial civilizations were trying to communicate, they were thinking along the same lines as our scientists. The architecture of listening that we've constructed goes far beyond individual telescopes like the Big Ear. Around the world, in remote deserts, on isolated mountaintops, in valleys shielded from human-made radio interference, we've built an array of listening posts, each contributing to our growing ability to eavesdrop on the cosmos. The Arecibo Observatory in Puerto Rico, until its tragic collapse in 2020, was one of the most powerful radio telescopes ever built. Its 305-meter dish nestled in a natural depression in the landscape. The Very Large Array in New Mexico consists of 27 separate dish antennas that can work together as a single instrument, providing unprecedented resolution in radio observations. The FAST telescope in China, completed in 2016, is currently the world's largest single-dish radio telescope, its 500-meter aperture capable of detecting incredibly faint signals from the depths of space. Each of these instruments represents not just a feat of engineering but an expression of hope, a concrete manifestation of our desire to connect with something beyond ourselves. When we build a radio telescope, we're not just constructing a scientific instrument, we're creating a bridge between Earth and the cosmos, a way for the universe to speak to us, and perhaps for us to speak back. The thousands of engineers, scientists and technicians who design, build and operate these telescopes are engaged in one of humanity's most audacious projects, the attempt to join a conversation that may have been going on for billions of years before we arrived. But listening to the cosmos presents challenges that go far beyond the technical difficulties of building and operating massive radio telescopes. The universe is a noisy place, filled with natural radio sources that can mask or mimic the kinds of signals we're searching for. Pulsars, those rapidly spinning neutron stars, emit regular pulses of radio waves that, when first discovered, were briefly thought to be alien beacons. Quasars, powered by supermassive black holes at the centres of distant galaxies, blast out radio waves that can outshine entire galaxies. Solar flares from our own sun can flood our receivers with radio noise. Even the cosmic microwave background, the faint echo of the Big Bang itself, creates a constant hiss of radio static that our instruments must filter out. And then there's the problem of human-made interference. As our civilization has become increasingly dependent on radio technology, we've filled the electromagnetic spectrum with our own signals. Cell phones, Wi-Fi routers, television broadcasts, satellite communications, radar systems. All of these create a cacophony of radio noise that can overwhelm the faint whispers from space. Radio telescopes must be located far from cities and towns, in radio-quiet zones where human-made transmissions are minimized. Even then, satellites passing overhead, aircraft with their radar and communication systems, and even spark plugs in nearby vehicles can create interference that must be carefully filtered out. The data processing challenges are equally daunting. A modern radio telescope can generate terabytes of data every day, far more than any human could possibly analyze manually. We've had to develop sophisticated computer algorithms to sift through this data, searching for patterns that might indicate an artificial signal. These algorithms must be smart enough to recognize potential signals of interest, while filtering out the vast amount of noise and interference. It's like trying to hear a whispered conversation in the middle of a hurricane, requiring both incredibly sensitive instruments and incredibly sophisticated analysis techniques. The search strategies we employ have evolved considerably since the early days of SETI. Some searches focus on targeted observations of specific stars that seem most likely to host habitable planets. We point our telescopes at sun-like stars, at stars with known planetary systems, at stars that are old enough for life to have evolved but not so old that they're nearing the end of their lives. Other searches take a wider approach, surveying large areas of the sky in the hope of catching signals from unexpected directions. Still others look for specific types of signals, narrowband transmissions like the WOW signal, pulsed signals that might represent deliberate beacons, or even more exotic possibilities like laser communications or gravitational wave signals. The philosophy behind our search has also evolved. Early SETI efforts were based on the assumption that alien civilizations would be actively trying to communicate with us, sending powerful beacons specifically designed to be detected by emerging technological civilizations like our own. But as our own technology has advanced, we've realized that there might be many other types of signals to search for. We might detect the electromagnetic leakage from an alien civilization's internal communications, the radio equivalent of overhearing a private conversation. We might detect the waste heat from massive engineering projects, the signatures of spacecraft propulsion systems, or even the atmospheric pollution from industrial civilizations. This broader perspective has led to new search strategies and new types of observations. Some researchers are looking for megastructures that advanced civilizations might build around their stars to harvest energy, so-called Dyson spheres or Dyson swarms. Others are searching for artificial illumination on the night sides of exoplanets, the alien equivalent of city lights. Still others are looking for atmospheric signatures that might indicate industrial activity, such as chlorofluorocarbons or other chemicals that don't occur naturally. Each of these search strategies represents a different hypothesis about how advanced civilizations might reveal themselves, intentionally or unintentionally. The patience required for this search cannot be overstated. We're looking for signals that may be extremely rare, that may only be detectable from specific directions at specific times, that may use technologies or frequencies we haven't yet thought to monitor. It's entirely possible that we've already detected signals from extraterrestrial civilizations, but haven't recognized them as such. The wow signal might not be unique. It might simply be the only one we've noticed so far. This possibility has led to efforts to reanalyze old data with new algorithms to look for patterns that might have been missed in earlier analyses. The international nature of the search for extraterrestrial intelligence reflects its significance for all of humanity. Scientists from dozens of countries collaborate on SETI projects, sharing data, techniques, and insights. The protocols for what to do if a signal is confirmed to be of extraterrestrial origin have been developed through international consultation, recognizing that such a discovery would belong to all of humanity, not to any single nation or group. This spirit of cooperation and shared purpose represents humanity at its best, working together toward a common goal that transcends political, cultural, and ideological boundaries. The role of amateur astronomers and citizen scientists in the search has become increasingly important. Projects like CTI at home have allowed millions of people around the world to contribute their computers' processing power to analyze radio telescope data. Other projects invite volunteers to visually inspect data, looking for patterns that automated algorithms might miss. This democratization of the search reflects a recognition that the discovery of extraterrestrial intelligence would be too important to leave to professionals alone. It's a search that belongs to all of us, that speaks to questions that every human being has wondered about. As our technology continues to advance, our ability to listen to the cosmos grows ever more sophisticated. New telescopes are being planned that will dwarf our current instruments in both size and capability. The Square Kilometre Array, currently under construction in Australia and South Africa, will consist of thousands of radio dishes and millions of antennas spread across thousands of kilometres, creating a collecting area of 1 square kilometre. This massive instrument will be able to detect incredibly faint signals, to survey the sky with unprecedented speed and sensitivity, and to observe multiple targets simultaneously. But perhaps even more important than the hardware improvements are the advances in our analysis techniques. Machine learning and artificial intelligence are revolutionizing our ability to process and understand the vast amounts of data our telescopes collect. These systems can learn to recognize patterns that human analysts might miss, to filter out interference more effectively, and to identify signals of interest in real time. As these technologies continue to improve, our chances of detecting faint or unusual signals increase dramatically. The architecture of listening we've built extends beyond just the search for extraterrestrial intelligence. The same telescopes and techniques we use to search for alien signals have revolutionized our understanding of the universe. We've discovered pulsars, quasars, and the cosmic microwave background. We've mapped the structure of our galaxy and others. We've detected organic molecules in interstellar space, suggesting that the building blocks of life are common throughout the cosmos. Each of these discoveries, while not directly related to the search for extraterrestrial intelligence, informs our understanding of the cosmic context in which life and intelligence might arise. The psychological and philosophical impact of our cosmic listening posts extends far beyond their scientific value. Every time we point a radio telescope at the stars, we're making a statement about who we are as a species. We're declaring that we're curious, that we're hopeful, that we believe the universe might be more than just empty space and burning gas. We're acknowledging that we might not be the pinnacle of cosmic evolution, that there might be others out there who have something to teach us. This humility, combined with the audacity of the search itself, represents a kind of spiritual maturity for our species. The Big Ear telescope that detected the WOW signal was demolished in 1998 to make way for a golf course, a fact that strikes many as tragically ironic. The instrument that may have detected humanity's first contact with extraterrestrial intelligence was destroyed for a recreational facility. But in another sense, the Big Ear's legacy lives on in every radio telescope that continues the search, in every scientist who analyzes the data, in every person who looks up at the night sky and wonders if someone out there is looking back. The architecture of listening that the Big Ear represented has grown far beyond any single instrument. As we continue to build and refine our cosmic listening posts, we're also building something less tangible but perhaps more important, a sense of ourselves as citizens of the cosmos. Every radio telescope is a reminder that Earth is not a closed system, that we're part of a vast universe, filled with wonders we are only beginning to discover. The search for extraterrestrial intelligence, whether or not it ever succeeds in detecting alien signals, has already succeeded in changing how we see ourselves and our place in the universe. The architecture of listening we've constructed is still in its infancy. We've been seriously searching for extraterrestrial signals for less than a human lifetime, a mere instant in cosmic terms. If the galaxy is filled with civilizations, but they're spread out in both space and time, it might take centuries or millennia of patient listening before we detect another signal. Or we might detect something tomorrow. This uncertainty is part of what makes the search so compelling. Every observation could be the one that changes everything, that transforms us from a species that wonders if we're alone to one that knows we're not. For 72 seconds on that August night in 1977, the universe spoke in a language we almost understood, delivering a message that continues to perplex and fascinate us nearly half a century later. Those 72 seconds have been analysed, debated, and pondered more thoroughly than perhaps any other brief moment in the history of astronomy. Each second of the WOW signal contains layers of mystery. Each measurement raises new questions, and each characteristic seems carefully chosen to maximize both detectability and enigma. Tonight, let's journey deep into those 72 seconds, exploring not just what happened, but what it might mean for our understanding of our place in the cosmos. To truly appreciate the significance of those 72 seconds, we need to understand exactly what the Big Ear telescope recorded. The signal didn't arrive all at once like a sudden shout. Instead, it rose and fell in intensity following a very specific pattern, a pattern that tells us something crucial about its origin. Imagine standing in a dark field with a flashlight that has a narrow beam. As you slowly rotate, the beam sweeps across the landscape, illuminating each object for just a moment before moving on. The Big Ear telescope worked on a similar principle, using Earth's rotation to sweep its narrow field of view across the sky. Any cosmic radio source would appear to grow stronger as it entered the telescope's beam, reach peak intensity when it was centered in the field of view, and then fade as Earth's rotation carried it out of sight. The wow signal followed this expected pattern perfectly. It started weak, grew to its maximum intensity, and then faded away, the entire process taking exactly 72 seconds. This precise timing tells us that whatever produced the signal was not moving relative to the stars. It wasn't an airplane, a satellite, or any other object in Earth's vicinity. The source was at a fixed position in space, far beyond our atmosphere, beyond our solar system, somewhere among the stars. This characteristic alone eliminated many potential explanations for the signal and firmly established its cosmic origin. But the true mystery of the wow signal lies not just in its timing, but in its characteristics. The signal was narrow band, meaning it was concentrated in a very small range of frequencies, less than 10 kilohertz wide. To understand how unusual this is, consider that natural cosmic radio sources typically emit across a wide range of frequencies. A pulsar, for instance, broadcasts across millions or billions of hertz. Even human-made signals often spread across wider frequency ranges. But the wow signal was like a pure note, a cosmic whistle at a single specific frequency. This narrow band characteristic is exactly what scientists expected an artificial signal to look like, because creating such a focused transmission requires technology, intention, and energy. The frequency itself, 1420 MHz, adds another layer of intrigue to our mystery. This is the frequency at which hydrogen atoms naturally emit radio waves when their electrons undergo a specific energy transition. Hydrogen is the simplest and most abundant element in the universe, the primary building block from which stars are formed, and the fuel that powers their nuclear furnaces. Every astronomer in the galaxy, regardless of their biological nature or evolutionary history, would know about this frequency. It's like a universal calling card, a frequency that says, if you understand basic physics, you'll be listening here. The choice of this frequency, if it was indeed a choice, demonstrates a sophisticated understanding of both physics and psychology. It's a frequency that would stand out against the cosmic background, that would be recognized as significant by any technological civilization, and that would be relatively free from natural interference. It's as if someone wanted to send a signal that would be noticed, that would be understood as artificial, but that wouldn't reveal too much about the sender. The frequency choice alone suggests intelligence, planning, and perhaps a desire to communicate or at least to be noticed. The intensity of the signal was remarkable as well. At its peak, the wow signal was about 30 times stronger than the background cosmic radio noise. This might not sound like much, but remember that the signal had travelled across interstellar space, weakening with distance according to the inverse square law. If the signal originated from a star system dozens or hundreds of light years away, the initial transmission power must have been enormous. We're talking about the kind of power that would require a significant fraction of a civilization's energy output, or alternatively, a highly focused directional transmission aimed precisely at our solar system. This raises fascinating questions about the nature and intent of the transmission. If it was omnidirectional, broadcasting in all directions simultaneously, the energy requirements would be staggering, suggesting a civilization with access to energy resources far beyond our current capabilities. If it was a directed beam, it implies that someone or something knew where to aim, that Earth or our solar system was specifically targeted. Either possibility is profound. An omnidirectional beacon suggests a civilization announcing its presence to the entire galaxy. A directed transmission suggests we were chosen, that something about our star system made it worth the effort to send a signal our way. The signal strength also showed no modulation, no variation that might encode information. It was like a pure carrier wave, steady and unchanging throughout its duration. This has puzzled researchers because if you're going to the trouble of sending an interstellar signal, why not include information? Why not encode data about your world, your species, your technology, or at least mathematical or physical constants that would prove the signal's artificial origin beyond any doubt? The absence of obvious modulation has led to several theories. Perhaps the signal was just a beacon, meant only to attract attention. Perhaps the information was encoded in ways we don't yet understand. Or perhaps we caught just a fragment of a longer transmission, missing the parts that contained the actual message. Let's pause for a moment to consider what those 72 seconds might have represented from the sender's perspective. If the signal was intentional, someone or something made a decision to transmit at that specific moment, at that specific frequency, with that specific power level. They might have been responding to something they detected from Earth, perhaps our early radio or television broadcasts that have been leaking into space since the early 20th century. Or they might have been following a predetermined schedule, broadcasting to different star systems in sequence, and Earth's turn came on August 15th, 1977. The brevity of the signal is itself a mystery. 72 seconds seems like such a short time to make contact across interstellar distances. If you were trying to communicate with an alien civilization, wouldn't you transmit for longer to increase the chances of detection? Unless, of course, 72 seconds was all the time available. Perhaps the transmission system could only maintain the required power output for that duration. Perhaps the sender's planet rotated, moving the transmitter out of alignment with Earth. Perhaps political, economic, or safety considerations limited the transmission time. Or perhaps 72 seconds was deemed sufficient for the signal's purpose, whatever that purpose might have been. The technical precision of the signal is worth contemplating in detail. The frequency was stable throughout the detection, showing no drift that might indicate a moving source or technical problems with the transmission equipment. This stability requires sophisticated technology, especially if the signal travelled across interstellar distances where various effects could cause frequency shifts. The signal appeared in only one of the Big Ear's two feed horns, exactly as expected for a distant point source. If it had been local interference, it likely would have appeared in both feed horns. These technical details, while perhaps mundane to non-specialists, paint a picture of a signal that behaves exactly as theoretical predictions suggested an extraterrestrial transmission would behave. Scientists have calculated that for the signal to have reached Earth with the observed intensity, assuming it came from a star system within a few hundred light years, the transmitter would have needed to be extraordinarily powerful. We're talking about power levels equivalent to or greater than our most powerful radio transmitters, but potentially operating continuously rather than in short bursts. This level of power generation and management implies a technological civilization with substantial resources and sophisticated engineering capabilities. It suggests beings who have moved beyond mere survival to projects that require coordinated effort and long-term planning. The timing of the signal within the context of cosmic evolution is intriguing as well. If the signal came from a star system 100 light-years away, it was transmitted in the 1870s, when humanity was just beginning to understand electromagnetism. If it came from 1,000 light-years away, it was sent when human civilization was in its medieval period. The senders, if they exist, had no way of knowing that Earth would have radio telescopes capable of detecting their signal when it arrived. This suggests either remarkable foresight, continuous transmission over long periods, or perhaps monitoring of Earth that revealed our technological development. But what if the 72 seconds weren't arbitrary? What if that specific duration was itself part of the message? In mathematics and physics, certain numbers have special significance. 72 is divisible by many factors: 2, 3, 4, 6, 8, 9, 12, 18, 24 and 36. It's the number of degrees in a pentagon's interior angle. It appears in various mathematical and geometric relationships. Perhaps a civilization trying to signal intelligence might choose a duration with mathematical significance, a subtle way of saying, this is not random, this is intentional. The single appearance of the signal, never to be detected again despite numerous attempts, adds perhaps the deepest layer of mystery. The Big Ear telescope continued to monitor the same region of sky for years afterward, but the signal never repeated. Other telescopes have searched the same coordinates, some with greater sensitivity than the Big Ear, but they've found only silence. This absence of repetition has led to numerous theories, each with its own implications for what the signal might have been. One possibility is that we witnessed a one-time event, perhaps the test of a powerful transmitter, or a signal sent to commemorate some special occasion in an alien civilization. Imagine if an extraterrestrial civilization decided to announce a major achievement, the completion of a massive engineering project, the unification of their planet, or the launch of their first interstellar spacecraft, by sending a powerful signal into space. We might have been lucky enough to be in the path of that announcement, catching a message that was never intended to repeat. Another theory suggests that the signal might repeat, but on a schedule we haven't yet determined. Perhaps it's broadcast once every few years, decades, or centuries. Our surveillance of that patch of sky, while extensive by human standards, represents only a tiny fraction of time in cosmic terms. If the signal repeats every 100 years, we'd need to maintain continuous observation for centuries to catch it again. This possibility reminds us of the vast timescales on which cosmic events unfold, timescales that dwarf human lifespans and even human civilization. The signal's characteristics have been compared to what we might expect from various natural phenomena, but none quite fit. Some scientists proposed that it might have been a gravitational lensing event, where the gravity of a massive object focused radio waves from a distant source, temporarily amplifying them to detectable levels. But the frequency specificity and narrow bandwidth argue against this explanation. Others suggested it might have been a previously unknown type of stellar phenomenon, perhaps a rare type of flare or emission from an exotic object. But decades of additional observations have failed to find any natural sources that produce signals quite like the WOW signal. The possibility that we detected a communication between two extraterrestrial civilizations, rather than a signal intended for us, opens up fascinating scenarios. Imagine two advanced civilizations maintaining contact across interstellar distances, using highly focused beams to minimize energy requirements. Earth might have passed through one of these beams by pure chance, like walking through a lighthouse beam on a foggy night. The 72 seconds would then represent the time it took for Earth to pass through the beam, after which it continued on to its intended destination, perhaps a star system in a completely different part of the galaxy. This interpretation suggests a galaxy where interstellar communication might be common, where civilizations separated by vast distances maintain contact through carefully aimed transmissions. We might live in a galaxy crisscrossed by invisible beams of information, a cosmic internet that we're not yet equipped to fully detect or understand. The wow signal might have given us a brief glimpse of this galactic communication network, like accidentally overhearing a phone conversation in a language we don't speak. The emotional and psychological impact of these 72 seconds extends far beyond their scientific significance. For Jerry Eman, who first noticed the signal in the data, it was a moment of recognition that something extraordinary had occurred. His handwritten "wow" has become one of the most famous annotations in scientific history, a very human response to a possibly non-human signal. For the scientists who have studied the signal since, it represents both a tantalizing hint of what might be possible and a frustrating mystery that resists solution. For humanity as a whole, those 72 seconds represent a moment when the abstract possibility of extraterrestrial intelligence became concrete. Before the wow signal, the search for extraterrestrial intelligence was largely theoretical, based on calculations and assumptions about what might be out there. After the wow signal, we had actual data, a real detection that demanded explanation. Even if the signal ultimately proves to have a natural or terrestrial origin, it has already succeeded in transforming how we think about our search for cosmic companions. The signal has inspired not just scientific research, but also philosophical and spiritual contemplation. What does it mean if we're not alone? How would contact with an extraterrestrial civilization change our understanding of ourselves, our place in the universe, our religions, our philosophies, our future? These questions, sparked by those 72 seconds, have enriched human thought and culture in ways that extend far beyond astronomy and SETI research. As technology has advanced, scientists have been able to conduct increasingly sophisticated analyses of the wow signal data, digital signal processing techniques that didn't exist in 1977 have been applied to the original recordings. Statistical analyses have been performed to determine the probability that the signal could have occurred by chance. Each new analysis confirms the signal's unusual nature while failing to provide a definitive explanation for its origin. The preservation of the original data from the wow signal represents an important lesson in scientific foresight. The computer printout with Eamon's annotation, the magnetic tapes with the raw data, the observational logs from that night, all have been carefully preserved. Future scientists with technologies we can't yet imagine may be able to extract information from this data that we currently miss. The 72 seconds of the wow signal have become a scientific time capsule waiting for future generations to unlock their secrets. Recent efforts to find the source of the wow signal have employed techniques that weren't available in 1977. Astronomers have used modern telescopes to search for stars or other objects at the signal's coordinates that might have been the source. They've looked for exoplanets in that region of sky, reasoning that a signal from an alien civilization would likely come from a planetary system. They've analysed the proper motion of stars, trying to determine which stars were at those coordinates in 1977, accounting for the movement of stars through space over the intervening decades. Some researchers have proposed that the WOW signal might have been caused by a comet or other solar system object passing through the Big Ear's field of view. Comets can emit radio waves at the hydrogen frequency as their ice sublimates in sunlight. But this explanation has been challenged by other scientists who point out that a comet would have been detected by other observations and wouldn't have produced the specific characteristics of the WOW signal. The debate continues, with each proposed explanation generating new questions and controversies. The cultural impact of those 72 seconds continues to grow. The WOW signal has appeared in countless documentaries, books, movies, and television shows. It has inspired music, art, and literature. It has become a symbol of mystery, possibility, and the human desire to connect with something beyond ourselves. This signal has entered our collective mythology, joining other mysterious events like the Tunguska explosion or the disappearance of Amelia Earhart as stories that capture our imagination precisely because they remain unsolved. Educational institutions use the WOW signal as a teaching tool, introducing students to concepts in astronomy, physics, statistics, and the scientific method. The signal demonstrates how science deals with anomalous data, how hypotheses are formed and tested, how uncertainty is quantified and communicated. It shows that science doesn't always provide clear answers, that mystery and uncertainty are part of the scientific process, not failures of it. The WOW signal emerged from the direction of Sagittarius, a constellation that from Earth's perspective lies toward the heart of our galaxy, where stars cluster more densely than in our local neighbourhood, where stellar birth and death play out on scales that dwarf human comprehension. To understand what might have produced that enigmatic signal, we need to explore this cosmic neighbourhood, to map the stellar geography of this region, and consider what kinds of worlds and civilizations might exist there. Tonight, let's take a journey through the stars of Sagittarius, exploring not just the astronomical facts but the profound possibilities that each star system represents. When we look towards Sagittarius on a clear dark night, we're looking into one of the richest star fields visible from Earth. The constellation itself, often depicted as a centaur archer, or more prosaically as a teapot, contains some of the most fascinating objects in our galaxy. The centre of the Milky Way lies in this direction, about 26,000 light-years from Earth, a supermassive black hole around which hundreds of billions of stars orbit in a cosmic dance that has been going on for billions of years. But the WOW signal didn't come from the galactic centre itself. It originated from a region closer to us, somewhere in the vast expanse between Earth and that distant cosmic hub. The exact distance to the source of the WOW signal remains unknown, one of the many mysteries that make it so intriguing. Without knowing the power of the original transmission, we can't calculate how far away it was. It could have come from a relatively nearby star system, perhaps only a few dozen light-years away, if the transmission was relatively modest in power. Or it could have originated hundreds or even thousands of light-years distant if the senders had access to enormous energy resources. This uncertainty means we must consider a vast volume of space, containing thousands of star systems, any one of which might have been the source. Let's begin our exploration with the stars closest to the WOW signal's coordinates. Within a few hundred light-years of Earth in that direction, there are numerous stars that could potentially host habitable planets. Many of these are stars similar to our Sun, what astronomers call G-type stars, that burn steadily for billions of years, providing the stable energy source that life might need to evolve and develop technology. These stars are neither too hot nor too cold, neither too massive nor too small, occupying what we might call the Goldilocks zone of stellar evolution. But perhaps we shouldn't limit ourselves to Sun-like stars. In recent years, astronomers have discovered that smaller, cooler stars, red dwarfs or M-type stars, might also be excellent hosts for habitable planets. These stars are far more common than Sun-like stars, making up about 75% of all stars in our galaxy. They burn their fuel much more slowly than larger stars, potentially shining steadily for trillions of years, far longer than the current age of the universe. If civilizations can arise on planets orbiting red dwarfs, they will have vast amounts of time to develop, to evolve, to spread throughout their stellar systems and perhaps beyond. In the direction of Sagittarius, we find examples of virtually every type of star known to astronomy. There are young, hot, blue stars, burning brilliantly but briefly, their intense radiation both creating and destroying the conditions for life. There are older, cooler red giants, stars that have exhausted the hydrogen in their cores and swollen to enormous size as they enter the final phases of their stellar evolution. There are binary and multiple star systems where two or more stars orbit around their common center of mass, creating complex and ever-changing patterns of light and gravity that would make any planets in these systems experience conditions unlike anything on Earth. One particularly intriguing aspect of the stellar neighborhood towards Sagittarius is its age distribution. Our galaxy is about 13.6 billion years old, nearly as old as the universe itself. Star formation has been going on throughout most of this time, meaning that some stars in that region are far older than our Sun, which is about 4.6 billion years old. If life arose on planets around these older stars, it could have had billions of years more than Earth life to evolve, to develop intelligence, to create technology. Civilizations around these ancient stars might have achieved levels of development that we can barely imagine, perhaps transcending biology itself, becoming something that we wouldn't even recognize as life. Consider for a moment what 1 billion years of additional evolution might mean. 1 billion years ago on Earth, the most complex life forms were simple, multicellular organisms. There were no plants or animals as we know them, no complex ecosystems, certainly no intelligence. In just the last 1 billion years, life on Earth has evolved from simple cells to the incredible diversity we see today, including beings capable of contemplating their own existence and searching for life elsewhere in the universe. What transformations might be possible with another 1 billion years? Or 2 billion? Or 5 billion? The chemical composition of stars in the direction of Sagittarius also tells an important story. Astronomers classify stars by their metallicity, the abundance of elements heavier than hydrogen and helium. These heavier elements, which astronomers somewhat confusingly call metals, even though they include elements like carbon, oxygen, and silicon, are essential for the formation of rocky planets and the chemistry of life as we know it. Stars that formed early in the galaxy's history have low metallicity because there hadn't been enough time for previous generations of stars to create and disperse heavy elements through supernovae. Younger stars, formed from gas enriched by billions of years of stellar evolution, have higher metallicity. The region towards Sagittarius contains stars with a wide range of metallicities, suggesting that planetary systems there could be quite diverse. Some might be rich in heavy elements, with large rocky planets and complex chemistry. Others might be metal poor, perhaps hosting different types of planets, or life based on different chemical foundations. This diversity increases the chances that somewhere in that vast stellar neighborhood, conditions were just right for life to arise and evolve to intelligence. The discovery of exoplanets has revolutionized our understanding of planetary systems, and many planets have been found in the direction of the WOW signal. These discoveries have shown us that planetary systems are far more diverse than we imagined based on our own solar system. There are hot Jupiters, massive gas giants that orbit closer to their stars than Mercury orbits our Sun. There are super-Earths, rocky planets larger than Earth but smaller than Neptune, a type of planet that doesn't exist in our solar system but appears to be common throughout the galaxy. There are planets in binary star systems, experiencing double sunrises and sunsets, seasons of incredible complexity. Some of the most intriguing exoplanet discoveries have been systems with multiple planets in or near the habitable zone, the region around a star where liquid water could exist on a planet's surface. These systems raise the fascinating possibility of life arising independently on multiple worlds in the same system, perhaps even exchanging material through meteorite impacts. Imagine a stellar system where life exists on 2 or 3 different planets, each following its own evolutionary path, perhaps eventually becoming aware of each other and establishing interplanetary civilizations long before attempting interstellar communication. The dynamics of stellar motion in our galaxy mean that the neighborhood towards Sagittarius is constantly changing. Stars orbit around the galactic center at different speeds and in slightly different planes, meaning that stellar neighbors millions of years ago are now scattered across the galaxy, and stars that are neighbors now are once far apart. This stellar mixing has profound implications for the spread of life through the galaxy. If life can be transferred between star systems, perhaps through meteorites ejected by impacts, carrying hardy microorganisms through interstellar space, then this mixing would help spread life throughout the galaxy over billions of years. The concept of panspermia, the idea that life can spread between planets and even between star systems, becomes particularly interesting when we consider the stellar density toward the galactic center. Stars are packed more closely together there, reducing the distances that any life-bearing material would need to travel. If panspermia is possible, the region towards Sagittarius might be especially rich in life, a cosmic garden where biological material has been shared between stellar systems for billions of years. But let's return to the specific stars that might have been the source of the WOW signal. Several candidate stars have been identified based on their position, distance, and characteristics. One intriguing possibility is that the signal came from a star similar to our Sun but older, perhaps a star that has already seen its planets evolve through the stages that Earth is currently experiencing. Such a star might host a civilization that has survived the challenges we currently face: climate change, nuclear weapons, artificial intelligence, and emerged as a stable, long-lived technological civilization capable of interstellar communication. Another possibility is that the signal came from a multiple star system. binary and triple star systems were once thought to be unlikely hosts for habitable planets because of the complex gravitational dynamics involved. But recent discoveries and simulations have shown that planets can exist in stable orbits in such systems, either orbiting close to one star or in wide orbits around all the stars. The environment on such planets would be unlike anything on Earth, with complex patterns of day and night, seasons that depend on the orbital dynamics of multiple stars, and perhaps unique evolutionary pressures that could lead to forms of life very different from terrestrial life. The stellar neighbourhood toward Sagittarius also contains various stellar remnants, white dwarfs, neutron stars, and possibly black holes, that tell the story of stellar death and recycling. These objects, while not likely to host life themselves, play important roles in the cosmic ecosystem. Supernovae, the explosive deaths of massive stars that create neutron stars and black holes, spread heavy elements through space, enriching the interstellar medium from which new stars and planets form. They also send shock waves through space that can trigger the collapse of gas clouds, initiating new rounds of star formation. Could an advanced civilization harness the energy of these stellar remnants? Science fiction has long imagined civilizations that build structures around black holes to extract energy from infalling matter, or that use the intense magnetic fields of neutron stars for purposes we can barely imagine. If such civilizations exist, they might produce signals unlike anything we normally associate with life, signals that we might detect but not recognize as artificial. The wow signal, with its unique characteristics, might have been our first glimpse of such exotic technology. The interstellar medium in the direction of Sagittarius is also rich and complex. Vast clouds of gas and dust, stellar nurseries where new stars are being born, fill the spaces between stars. These clouds contain organic molecules, the building blocks of life, that form through chemical reactions in space. Radio astronomers have detected dozens of different organic molecules in these clouds, including amino acids, the components of proteins. This cosmic chemistry suggests that the raw materials for life are common throughout the galaxy, waiting for the right conditions to assemble into living systems. These interstellar clouds also affect how signals propagate through space. Radio waves can be absorbed, scattered, or have their frequencies shifted as they pass through clouds of gas and dust. The fact that the wow signal reached Earth with such clarity suggests that the path between its source and Earth was relatively clear, or that the signal was powerful enough to overcome any interference. This gives us clues about both the location of the source and the nature of the transmission. The age of the universe in the direction of Sagittarius opens up temporal possibilities that are mind-bending to contemplate. Light and radio waves from that region show us not how things are now, but how they were when the signals began their journey. If the wow signal came from a star 200 light-years away, we detected a transmission from the year 1777, when the American Revolution was underway and Mozart was composing his piano sonatas. The civilization that sent it, if it still exists, has had 2 additional centuries of development. They might have advanced far beyond the technology that produced the signal, or they might have disappeared entirely, their signal a ghost echo of a civilization that no longer exists. This temporal displacement adds a poignant dimension to our search for extraterrestrial intelligence. We're not just separated from potential cosmic neighbours by vast distances, we're separated by time itself. Even if we detected a signal today and sent a response immediately, it would take centuries or millennia for our response to reach its destination, and an equal time for any reply to return to Earth. This means that communication with extraterrestrial civilizations, if it ever occurs, will be a multi-generational project requiring a level of patience and long-term thinking that challenges our species' typical time horizons. The diversity of stellar environments in the direction of Sagittarius suggests that if life exists there, it could take forms vastly different from terrestrial life. Planets orbiting red dwarf stars would be tidally locked, with one side always facing the star and the other in eternal darkness. Life on such worlds might be concentrated in the twilight zone between eternal day and eternal night, or it might have evolved to migrate between the two hemispheres. Planets in binary systems might experience regular cycles of extreme heat and cold as the stars orbit each other, selecting for organisms capable of surviving dramatic environmental changes. High-gravity worlds might host life forms that are low and spread out, while low-gravity worlds could support tall, delicate organisms that would collapse under Earth's gravity. Worlds with thick atmospheres might favour acoustic communication over visual, leading to civilizations that see with sound. Planets orbiting variable stars might have life that goes dormant during stellar flares and active during quiet periods. Each of these environments would shape not just the biology of any life that arose there, but also its psychology, its culture, its technology, and its approach to understanding and communicating with the universe. The metallicity variations in stars towards Sagittarius could also affect the development of technology. Civilizations on metal-poor worlds might never develop electronics as we know them, instead perhaps developing organic or crystalline technologies that we wouldn't recognize. Conversely, civilizations on metal-rich worlds might have access to elements rare on Earth, enabling technologies that we haven't imagined. The wow signal might have been produced by a technology so different from our own that we can't recognize the principles behind it. Like showing a radio to someone from the Stone Age. Since that remarkable night in 1977 when the wow signal announced itself to humanity, there have been other whispers from the cosmos, other moments when our instruments detected something unusual, something that made scientists pause and wonder if we might be hearing echoes of intelligence from across the vast expanses of space. These signals, some lasting microseconds, others persisting for hours, form a growing catalogue of cosmic mysteries that might, just might, represent attempts at communication from civilizations among the stars. Tonight, let's explore these other enigmatic transmissions, these echoes we've almost heard, and consider what they might tell us about a universe that could be alive with intelligence. The story of these cosmic whispers doesn't begin or end with the wow signal. In fact, the history of radio astronomy is peppered with detections that have made scientists' hearts race. Signals that seem too regular, too narrow band, or too unusual to be natural phenomena. Each of these detections has taught us something about the universe, even when they've ultimately been explained by natural processes. And perhaps more importantly, they've refined our understanding of what we should be looking for, what characteristics would definitively identify a signal as artificial rather than natural. One of the most intriguing categories of signals that have captured scientists' attention in recent years are fast radio bursts, or FRBs. These are intense pulses of radio energy that last only milliseconds, but release as much energy as our sun produces in days or even years. The first FRB was discovered in 2007 when astronomers were reviewing archival data from 2001, finding a burst so powerful and brief that it was initially dismissed as equipment malfunction. But as more FRBs were detected, it became clear that these were real astronomical phenomena, coming from sources billions of light-years away. What makes FRBs particularly fascinating in the context of our search for extraterrestrial intelligence is their diversity, and in some cases, their regularity. Most FRBs appear to be one-time events, flashing once and never repeating. But some FBs repeat, sending out multiple bursts over days, months, or years. One particular source, designated FRB 121102, has produced hundreds of detected bursts, sometimes remaining quiet for months before suddenly becoming active again. Even more intriguingly, some repeating FRBs show periodicity in their activity, cycling through active and quiet phases with clockwork regularity. The discovery of FRB 180916, which shows a 16.35-day period in its activity, sent ripples of excitement through the astronomical community. This periodicity is difficult to explain through natural processes alone. Some scientists have proposed that it could be caused by a neutron star in a binary system, with the bursts only visible when the neutron star is in a particular part of its orbit. Others have suggested more exotic explanations involving magnetas, highly magnetized neutron stars, or even cosmic strings, hypothetical defects in space-time left over from the Big Bang. But there's another possibility that lurks in the back of many minds. Could some FRBs be artificial in origin? Consider what an advanced civilization might do if it wanted to announce its presence to the universe. Building a beacon that broadcasts continuously in all directions would require enormous amounts of energy. But sending brief, powerful pulses at regular intervals would be much more energy efficient, while still being detectable across vast distances. The periodicity could encode information, mathematical constants, physical measurements, or even just a pattern complex enough to indicate intelligence. Some FRBs show frequency structure within their brief duration, with the frequency sweeping from high to low in a way that could potentially encode information. The distances to FRBs, billions of light-years in most cases, argue against them being signals from extraterrestrial civilizations, at least civilizations as we typically imagine them. The energy requirements to send a signal that far are almost incomprehensible. But this assumes that the civilizations are similar to us in scale and capability. What if some FRBs are the signatures of Type 2 or Type 3 civilizations on the Kardashev scale? Civilizations that harness the entire energy output of their star or even their galaxy. To such civilizations, sending signals across billions of light-years might be no more difficult than radio broadcasting is to us. Another class of signals that has intrigued scientists are the so-called peritons, brief radio pulses that were detected at the Parkes Observatory in Australia. For years, these signals puzzled astronomers because they had some characteristics of extraterrestrial signals but didn't quite match what was expected from cosmic sources. They appeared to come from all directions rather than from specific points in the sky, and they occurred at seemingly random times. The mystery was solved in 2015 when scientists discovered that peritons were caused by microwave ovens being opened before their cycles completed, releasing a burst of radio waves that the sensitive telescope detected. This discovery was both disappointing and instructive, reminding us that not all mysterious signals come from space, and highlighting the importance of rigorous investigation. But not all mysterious signals have such mundane explanations. In 2016, Russian astronomers announced the detection of a strong signal from the direction of HD 164595, a sun-like star about 95 light-years away known to have at least one planet. The signal was detected by the Ratan 600 radio telescope in the Caucasus Mountains, and its characteristics suggested it could be artificial. The star's similarity to our Sun and the presence of a confirmed planet made it an intriguing candidate for hosting life. However, follow-up observations by other telescopes failed to detect the signal again, and it was eventually attributed to terrestrial interference, possibly from a military satellite. Still, the brief excitement surrounding this detection reminded the world that the search for extraterrestrial intelligence continues, and that any day could bring a discovery that changes everything. The SETI Institute and other organizations have detected numerous signals over the years that have raised hopes before ultimately being explained. The weird signal detected in 2016, coming from the vicinity of a red dwarf star called Ross 128, showed unusual characteristics that didn't match known natural sources or typical interference. Follow-up observations suggested it was likely caused by satellites in geostationary orbit, but the process of investigation advanced our understanding of how to distinguish between terrestrial and extraterrestrial signals. In 2019, astronomers detected a narrow-band signal coming from Proxima Centauri, our nearest stellar neighbour, which hosts at least 2 planets, one of which is in the habitable zone. Designated BLC1, Breakthrough Listen Candidate 1, this signal persisted for hours and showed a frequency drift consistent with a source on a rotating planet. The excitement was palpable. Could our nearest neighbour be home to a technological civilization? Extensive analysis over the following years ultimately concluded that the signal was most likely terrestrial interference, but the detection and investigation process demonstrated how seriously the scientific community takes potential SETI signals and how sophisticated our analysis techniques have become. What's particularly interesting about these various detections is how they've shaped our understanding of what we're looking for. Each false alarm has taught us something about the types of interference we need to filter out, the characteristics that distinguish natural from potentially artificial signals, and the importance of immediate follow-up observations. We've learned that signals appearing in multiple telescopes simultaneously are likely terrestrial, that signals that don't show the expected Doppler shift from Earth's motion are probably local, and that the frequency structure of a signal can reveal much about its origin. The search has also revealed unexpected natural phenomena that, while not signs of extraterrestrial intelligence, have expanded our understanding of the universe. Pulsars, when first discovered in 1967, were briefly designated LGM-1, Little Green Men 1, because their regular pulses seemed too artificial to be natural. We now know they're rapidly rotating neutron stars, but their discovery opened up entirely new fields of astronomy. Similarly, the investigation of potential SETI signals has led to discoveries about stellar flares, magnetospheric phenomena, and the behavior of interstellar plasma. Some researchers have suggested that we might be looking for the wrong types of signals entirely. Our searches have largely focused on radio waves because that's a technology we understand and use. But what if advanced civilizations have moved beyond radio? They might communicate using laser pulses, gravitational waves, neutrino beams, or technologies we haven't yet discovered. The wow! Signal and other radio detections might be the equivalent of finding stone tools, evidence of intelligence, but from civilizations at a particular technological stage that they might quickly surpass. Optical CT, the search for laser pulses from extraterrestrial civilizations, has detected several interesting signals over the years. Brief, intense flashes of light from the direction of certain stars have been observed that don't match any known natural phenomena. While none have been confirmed as extraterrestrial, they remind us that intelligence might reveal itself in many different ways. This civilization might use lasers for communication because they can be more tightly focused than radio waves, allowing for more efficient point-to-point communication across interstellar distances. The temporal aspect of these signals adds another layer of complexity to our search. A signal that repeats every few years might be missed if we only observe a particular star for a few hours or days. A civilization might broadcast on a schedule that makes sense to them but seems random to us. They might transmit only when their planet's orbit brings them into alignment with target stars, or only during certain phases of their star's activity cycle. The wow! Signal's failure to repeat might not mean it was a one-time event. It might mean we haven't waited long enough or looked at the right time. Some scientists have proposed that we might have already detected numerous signals from extraterrestrial civilizations, but haven't recognized them as such. These signals might be buried in the noise, too weak for our current detection algorithms, but perhaps recoverable with future technology. Or they might be in plain sight, but encoded or modulated in ways we don't expect. The history of science is full of discoveries that were missed because we didn't know what to look for, from the cosmic microwave background that was initially dismissed as pigeon droppings to dark energy that was hiding in supernova data for years before being recognized. The possibility of signal contamination or confusion is also worth considering. As Earth becomes increasingly noisy in the radio spectrum with satellites, cell towers, and other technologies filling the airwaves, it becomes harder to distinguish potential extraterrestrial signals from terrestrial interference. Some scientists worry that we might have already received and dismissed genuine extraterrestrial signals because they were contaminated by or confused with human-made signals. This is one reason why radio telescopes are increasingly being built in remote locations far from human activity. The emotional and psychological impact of these near misses and false alarms is significant. Each time a potentially artificial signal is detected, there's a surge of excitement in the scientific community and the public. Even when these signals are ultimately explained by natural or terrestrial causes, they serve to remind us of the possibility that we might not be alone. They keep the dream alive, the search active, and the funding flowing for SETI research. In a sense, these false alarms are valuable because they maintain interest in and support for the search. The protocol for handling potential SETI detections has been refined through these experiences. Scientists have developed careful procedures for verifying signals, including immediate notification of other observatories for confirmation, careful analysis to rule out terrestrial interference, and protocols for public announcement if a signal is confirmed. The fact that we have these protocols in place, tested through numerous false alarms, means we're better prepared for the day when we might detect a genuine signal from an extraterrestrial civilization. The technological advances driven by the search for these elusive signals have benefits beyond CT. The development of more sensitive receivers, better signal processing algorithms, and techniques for filtering out interference have applications in communications, radar, and other fields. The massive data sets generated by SETI searches have driven advances in data storage, processing and analysis that benefit many areas of science. In this sense, even if we never detect a signal from an extraterrestrial civilization, the search itself has been valuable. Some of the most intriguing signals are those that show characteristics of both natural and artificial origin, defying easy classification. These weird signals, as astronomers sometimes call them, might represent unknown natural phenomena, or they might be our first glimpses of technology so advanced that they blur the line between natural and artificial. Arthur C. Clarke's famous third law states that any sufficiently advanced technology is indistinguishable from magic. Perhaps we should add corollary. Any sufficiently advanced technology might be indistinguishable from nature. The geographic distribution of signal detections is also interesting. Different telescopes in different parts of the world have detected different types of anomalous signals, suggesting that there might be many more such signals that we're missing simply because we're not looking in the right place at the right time. The wow! Signal was detected by a telescope in Ohio, looking at a particular patch of sky at a particular moment. How many other wow signals might have passed by undetected because no telescope happened to be pointed in the right direction? This realization has led to proposals for all-sky, all-the-time monitoring systems that could detect transient signals from any direction at any time. Projects like the Square Kilometre Array, when completed, will have the capability to monitor large portions of the sky simultaneously, increasing our chances of detecting brief or directional signals. Future space-based radio telescopes, free from terrestrial interference and able to observe continuously without the interruption of day-night cycles, might finally give us the comprehensive coverage needed to detect signals that current ground-based telescopes miss. The possibility that some signals might be deliberately designed to be difficult to detect adds another dimension to our search. An advanced civilization might encode their signals in ways that only other advanced civilizations could detect, using it as a kind of intelligence test. The wow! Signal's specific characteristics, its frequency, duration and intensity, might have been carefully chosen to be detectable but not immediately understandable, prompting exactly the kind of decades-long investigation and speculation that has occurred. What if the wow signal was only the beginning? Documentary for Sleep. Part 2, The Cosmic Symphony, Chapters 6 to 9. Chapter 6. The mathematics of contact numbers might be the only language that transcends worlds, the universal grammar of intelligence that could bridge the gap between minds separated by vast distances and even vaster differences in biology, culture, and perception. As we contemplate the wow signal and what it might represent, we find ourselves drawn into the profound relationship between mathematics and communication, between the abstract patterns that govern the universe and the concrete possibility of contact with other intelligences. Tonight, let's explore how mathematics might serve as the foundation for interstellar communication, how the wow signal's characteristics align with mathematical predictions of what an intentional message might look like, and how the quiet calculations of possibility reveal both hope and humility in our search for cosmic companions. Mathematics is often called the universal language, and for good reason. The ratio of a circle's circumference to its diameter is pi, whether you're on Earth, in the Andromeda Galaxy, or at the edge of the observable universe. 2 + 2 = 4, regardless of whether you have tentacles, wings, or cybernetic implants. The prime numbers 2, 3, 5, 7, 11, 13, and so on, form the same sequence everywhere, a pattern that emerges from the fundamental nature of counting itself. If we ever receive a message from an extraterrestrial civilization, it will likely begin with mathematics, because mathematics is the one thing we can be certain we have in common. The idea of using mathematics for interstellar communication isn't new. As far back as the 19th century, mathematicians and astronomers proposed various schemes for signalling to hypothetical Martians or other cosmic neighbours using geometric patterns or mathematical sequences. Carl Friedrich Gauss, one of history's greatest mathematicians, supposedly suggested planting forests in Siberia in the shape of a right triangle with squares on, each side demonstrating the Pythagorean theorem on a scale visible from space. While this particular story may be apocryphal, it illustrates a profound insight. Mathematical truths are discoverable by any intelligence capable of abstract thought, making them ideal for establishing communication. The wow. Signal's frequency of 1420 MHz is itself a mathematical choice of profound significance. This frequency corresponds to the 21 centimetre wavelength emission of neutral hydrogen, arising from a quantum mechanical transition in the hydrogen atom's ground state. The physics behind this emission involves some of the most fundamental constants of nature. Planck's constant, the speed of light, the mass of the electron, and the fine structure constant. Any civilization that has developed radio astronomy would know about this frequency, would understand its significance, and would likely monitor it or use it for communication attempts. But the mathematical significance of the wow signal goes beyond just its frequency. The signal's narrow bandwidth suggests a level of technological sophistication that requires precise mathematical control. Creating a signal that narrow requires careful engineering, feedback systems that maintain frequency stability, and an understanding of how electromagnetic waves propagate through space. It's like playing a single, pure note on a cosmic instrument, a feat that announces not just presence but capability, not just intelligence but technological mastery based on mathematical principles. Consider what would be required to send a signal like the wow, signal across interstellar distances. The inverse square law tells us that the intensity of electromagnetic radiation decreases with the square of the distance from the source. If the signal travelled 100 light-years to reach us, it had spread out over a sphere with a surface area of about 400,000 square light-years by the time it arrived. The fact that it was still detectable means the original transmission must have been extraordinarily powerful or extraordinarily focused, or both. The mathematics of this is staggering. We're talking about energy levels and engineering precision that push the boundaries of what we consider possible. The duration of the signal, those famous 72 seconds, might itself be mathematically significant. 72 has interesting mathematical properties that could make it a natural choice for a civilization trying to indicate intelligence. It's highly composite, meaning it has more divisors than any smaller positive integer has. It's divisible by 2, 3, 4, 6, 8, 9, 12, 18, 24, and 36. In geometry, it's the number of degrees in the interior angle of a regular pentagon. It appears in various mathematical sequences and has significance in different number systems. A civilization choosing to transmit for exactly 72 seconds might be embedding a mathematical clue in the very duration of their signal, the search for patterns within the wow. Signals data has occupied mathematicians and computer scientists for decades. Even though the signal appeared to be unmodulated, a steady carrier wave without obvious information content, there could be subtle patterns that we haven't yet detected. Information could be encoded in phase variations too small for the big ear's equipment to detect, in polarization changes that weren't recorded, or in relationships between multiple frequency components that appeared as a single narrow band signal to our instruments. The mathematics of signal processing tells us that there are many ways to hide information in what appears to be a simple signal. One fascinating aspect of using mathematics for interstellar communication is the concept of anti-cryptography, making messages as easy as possible to decode rather than as difficult as possible. If you want to communicate with an unknown civilization, you need to make your message self-decoding, providing enough structure and redundancy that the recipients can figure out how to read it without any prior knowledge of your encoding scheme. This might involve starting with simple mathematical concepts and building up to more complex ones, creating a kind of cosmic primer that teaches the recipient how to understand the rest of the message. The Drake equation, formulated by astronomer Frank Drake in 1961, represents one of the most famous attempts to use mathematics to estimate the probability of extraterrestrial intelligence. The equation multiplies together various factors: the rate of star formation in our galaxy, the fraction of stars with planets, the fraction of planets that could support life, the fraction where life actually develops, the fraction where intelligence evolves, the fraction that develops technology, and the length of time such civilizations survive. While we don't know the values of most of these factors, the equation provides a mathematical framework for thinking about the likelihood that the WOW signal came from an extraterrestrial civilization. Using conservative estimates in the Drake equation suggests there could be anywhere from a handful to millions of technological civilizations in our galaxy at any given time. The mathematics tells us that even if the probability of life arising on any given planet is extremely small, the sheer number of planets in our galaxy, hundreds of billions, means that life, and possibly intelligent life, should exist elsewhere. The WOW signal might be our first piece of empirical evidence that the Drake equation's optimistic solutions are correct. Information theory, developed by Claude Shannon in the 1940s, provides another mathematical lens through which to view the WOW signal. Shannon's work established fundamental limits on how much information can be transmitted through a communication channel, and how to design signals that can be reliably detected despite noise and interference. The characteristics of the WOW signal, its narrow bandwidth, its specific frequency, its signal-to-noise ratio, align well with what information theory suggests for an optimal beacon signal designed to be detected across interstellar distances. The concept of algorithmic information theory adds another layer to our mathematical understanding of potential extraterrestrial signals. This field deals with the complexity of information and the shortest possible description of a pattern or message. A signal from an intelligent source should have high algorithmic information content. It should contain patterns that are neither completely random nor boringly repetitive. The WOW signal's combination of specific characteristics, frequency, duration, intensity, and unrepeated nature gives it an intermediate level of complexity that's consistent with an intentional transmission. Prime numbers have long been considered ideal for interstellar communication because they're mathematically significant, but don't occur naturally in physical processes. A signal that pulses with prime number intervals 2, 3, 5, 7, 11, and so on, would immediately stand out as artificial. While the wow signal didn't show obvious prime number patterns, the possibility remains that such patterns were embedded in ways our instruments couldn't detect. Future signals might use prime numbers more explicitly, creating an unmistakable mathematical signature of intelligence. The Fibonacci sequence 1, 1, 2, 3, 5, 8, 13, 21, and so on, where each number is the sum of the two preceding ones, represents another mathematical pattern that could be used for interstellar communication. This sequence appears throughout nature, from the spiral of galaxies to the arrangement of seeds in a sunflower, suggesting it might be recognized by intelligences that evolved in completely different environments. A signal modulated according to the Fibonacci sequence would be both natural enough to propagate well through space and artificial enough to indicate intelligence. Mathematical constants like pi, e, Euler's number, and the golden ratio could serve as calling cards in interstellar messages. These constants emerge from fundamental mathematical relationships and would be known to any technologically advanced civilization. A signal that encodes these constants to high precision would be almost impossible to explain as a natural phenomenon. The fact that the wow signal appeared at the hydrogen line frequency might itself be seen as a use of a universal constant, the physics of hydrogen, as an attention-getting device. The mathematics of probability helps us understand both the likelihood of detecting extraterrestrial signals and the challenges involved in the search. If civilizations broadcast in random directions at random times, the probability of one of their signals intersecting with Earth while we happen to be listening in the right direction at the right frequency is vanishingly small. This suggests that either civilizations broadcast very frequently or for very long periods, or that they target specific star systems that they think might harbour life, or that we've been extraordinarily lucky to detect even one signal. Game theory, the mathematical study of strategic decision-making, offers insights into why civilizations might or might not choose to broadcast their presence. Broadcasting announces your location to the entire galaxy, potentially attracting attention from hostile civilizations. This is sometimes called the dark forest hypothesis, the idea that civilizations remain quiet to avoid detection by dangerous neighbors. But game theory also suggests that cooperation can emerge even among potential competitors, and that the benefits of joining a galactic community might outweigh the risks. The wow signal, if artificial, represents a civilization that chose to take the risk of announcing itself. The mathematics of error correction could play a crucial role in interstellar communication. Any signal travelling across interstellar distances will be affected by various forms of interference and distortion. Sophisticated error-correcting codes based on mathematical principles could ensure that messages remain decodable despite this degradation. The apparent simplicity of the wow signal might mask complex error correction encoding that we don't yet know how to recognize or decode. Chaos theory and nonlinear dynamics provide another mathematical perspective on the search for extraterrestrial intelligence. These fields show us that simple rules can generate incredibly complex patterns, and that small changes in initial conditions can lead to vastly different outcomes. This has implications for the development of life and intelligence. It might be relatively common for simple life to arise, but rare for it to evolve to intelligence, or vice versa. The wow signal might represent a brief window where all the chaotic factors aligned to allow detection of an extraterrestrial transmission. The mathematics of network theory could help us understand how interstellar civilizations might organize their communications. If multiple civilizations exist in our galaxy, they might form a communication network, with signals relayed from one civilization to another. Wow! Signal might have been part of such a network, a message passing through our region of space on its way to another destination. Understanding the mathematics of how such networks might be organized could help us predict where and when to look for signals. Quantum mechanics adds yet another layer of mathematical complexity to the possibility of interstellar communication. Quantum entanglement, while it can't be used to transmit information faster than light, could potentially be used to create unclonable signatures that verify the authenticity of a message. A civilization might use quantum properties of photons to create signals that can't be faked or altered, providing a mathematical guarantee of their origin. The technology to detect such quantum signatures doesn't exist yet, but it represents a future direction for SETI research. The mathematical concept of dimensionality could also play a role in interstellar communication. While we perceive 3 spatial dimensions plus time, string theory and other advanced physics theories suggest there might be additional dimensions that we can't directly perceive. An advanced civilization might use these extra dimensions for communication in ways we can't yet detect. The wow signal might be just the 3-dimensional shadow of a higher dimensional transmission, like seeing the shadow of a 3-dimensional object on a 2-dimensional wall. Statistical analysis of the wow signal has revealed its extraordinary nature in mathematical terms. The probability of such a signal occurring by chance through natural processes or random noise is extremely small, perhaps 1 in millions or billions. This statistical significance is what has kept scientists interested in the signal for decades. It's not just that the signal was unusual, it's that it was unusual in exactly the ways that theoretical predictions suggested an extraterrestrial signal would be unusual. The mathematics of compression could be crucial for interstellar messages. Sending information across interstellar distances is expensive in terms of energy and time, so civilizations would likely compress their messages as much as possible. Maximum compression makes a signal look almost random. It has no obvious patterns because all redundancy has been removed. The wow signal's apparent lack of modulation might not mean it carried no information. It might mean the information was so efficiently compressed that we can't recognize it as information. Fractals, mathematical patterns that repeat at different scales, offer another possible framework for interstellar communication. Fractal patterns appear throughout nature, in coastlines, clouds, and biological structures, suggesting they might be universally recognized. A signal with fractal properties would stand out as potentially artificial, while still being aesthetically and mathematically interesting. The search for fractal patterns in the wow signal and other candidate signals continues, aided by increasingly sophisticated mathematical analysis tools. The mathematical relationship between energy, information, and entropy provides fundamental constraints on interstellar communication. The laws of thermodynamics tell us that transmitting information requires energy and increases entropy. An advanced civilization would understand these constraints and design their communications accordingly. The power level of the wow signal, combined with its information theoretic properties, suggests a civilization that understands these mathematical relationships and has optimized their transmission within these constraints. If the universe teems with possibilities for life, if billions of planets orbit within habitable zones around their stars, if the chemistry of life appears to be common throughout the cosmos, then why does the universe seem so quiet? This is the heart of what scientists call the Fermi paradox, or the Great Silence, a mystery that becomes even more perplexing when we consider signals like the wow, signal that hint at intelligence but never repeat, never develop into clear communication, never lead to the contact that our mathematics and logic suggest should be possible. Tonight, let's explore this profound paradox, considering not just why the universe might seem silent, but what that silence itself might be telling us about the nature of intelligence, communication, and our cosmic future. The Fermi paradox takes its name from physicist Enrico Fermi, who, during a lunch conversation in 1950, famously asked, "Where is everybody?" The paradox arises from a simple chain of reasoning. Our galaxy is billions of years old and contains hundreds of billions of stars. Even if only a tiny fraction of these stars have planets capable of supporting life, and only a tiny fraction of those actually develop life, and only a tiny fraction of those evolve intelligence, there should still be millions of technological civilizations in our galaxy. Given the age of the galaxy, some of these civilizations should be millions or billions of years more advanced than us. Such civilizations should have had ample time to colonize the entire galaxy, or at least make their presence known through signals or artifacts. Yet we see no convincing evidence of their existence. The universe appears silent, empty of the intelligent signals we might expect. The wow signal makes this paradox even more acute. Here we have what might be exactly the kind of signal we'd expect from an extraterrestrial civilization, narrow band, at a significant frequency, from a fixed point in space. But it appeared once and vanished, like a cosmic knock on the door with no one there when we opened it. If civilizations are trying to communicate, why don't they persist? If they're not trying to communicate, what was the wow signal? The silence that followed those 72 seconds is perhaps more mysterious than the signal itself. One possible resolution to the paradox is that we're simply not listening properly. Perhaps civilizations communicate in ways we haven't discovered, using physics we don't yet understand. We've only been capable of radio astronomy for less than a century, a mere eye blink in cosmic time. It would be presumptuous to assume that radio waves, which we've used for only about 100 years, represent the ultimate communication technology. Perhaps advanced civilizations quickly move beyond radio to something better. Tighter beams of neutrinos, modulated gravitational waves, or technologies that exploit quantum entanglement in ways we haven't imagined. Consider the possibility that the silence is an illusion created by our technological limitations. Imagine trying to intercept modern internet traffic with a telegraph key. You might detect electromagnetic activity, but you'd have no way to decode the complex digital protocols being used. The wow signal and other anomalous detections might be fragments of communications using protocols so advanced that we perceive them as noise or simple carrier waves. The universe might be filled with conversations we're not equipped to understand, like being deaf at a concert, feeling the vibrations but missing the music. Another explanation for the Great Silence is the zoo hypothesis, the idea that advanced civilizations are aware of us, but have chosen not to make contact, perhaps to avoid interfering with our natural development. Earth might be designated as a kind of cosmic nature preserve, with extraterrestrial civilizations observing us but maintaining a policy of non-interference. The wow signal in this scenario might have been a mistake, a transmission that accidentally leaked through whatever barriers keep us isolated. This would explain why it never repeated. Perhaps someone realized their error and ensured it wouldn't happen again. The temporal aspect of the paradox is often underappreciated. Civilizations might rise and fall on timescales that make communication between them unlikely. If the average technological civilization survives for only a few thousand years before destroying itself or transcending to something we wouldn't recognize as technological, then the galaxy might be full of civilizations that never overlap in time. We might be surrounded by the ruins of dead civilizations and the seeds of future ones, existing in a brief window between waves of intelligence. The wow signal might have been the last transmission of a dying civilization, or the first experiment of a newly technological one. The transcension hypothesis offers another intriguing possibility. Perhaps advanced civilizations don't expand outward into space, but instead turn inward, exploring inner space rather than outer space. They might upload their consciousness into virtual realities, compress themselves into artificial black holes, or transcend to higher dimensions. Such civilizations would be invisible to our telescopes, having little interest in the crude physical universe we inhabit. The wow signal might have been sent by a civilization on the verge of transcension, a farewell message to the universe they were about to leave behind. Distance and energy considerations provide a more prosaic, but perhaps more likely explanation for the silence. Even if civilizations are common, the vast distances between stars make communication extraordinarily difficult. The energy required to send a signal that can be detected across hundreds or thousands of light years is enormous. Civilizations might broadcast occasionally, but the odds of us happening to be listening in the right direction, at the right frequency at the right time, are astronomically small. The wow signal might represent one of the rare occasions when all these factors aligned, a cosmic coincidence that might not repeat for centuries or millennia. The dark forest hypothesis presents a darker explanation for the silence. In this scenario, civilizations remain quiet because broadcasting one's presence is dangerous. The galaxy might be full of civilizations, but they're all hiding, afraid that revealing themselves will attract the attention of more powerful and potentially hostile civilizations. The few civilizations that do broadcast, perhaps sending signals like the wow signal, are quickly silenced, either learning to hide or being eliminated. This would create a galaxy that appears empty, but is actually full of civilizations maintaining radio silence for their own survival. Cultural and biological factors might also contribute to the silence. We assume that other intelligences would be interested in communication and exploration, but these might be uniquely human drives. Alien psychologies shaped by different evolutionary pressures might have no interest in making contact with other species. They might be solitary by nature, finding the idea of communication with aliens as appealing as we might find communication with bacteria. The wow signal might have been sent by the alien equivalent of a rebellious teenager acting against the norms of their civilization. The possibility that we're actually early in the universe's history provides another perspective on the silence. While the universe is 13.8 billion years old, it will continue to exist for trillions of years. We might be among the first technological civilizations to arise, with the universe's age of intelligence still to come. The conditions for complex life, Sufficient heavy elements, stable stars, low radiation environments have only existed for a fraction of the universe's future history. The wow signal might not be from an ancient advanced civilization, but from another young civilization like our own, taking its first tentative steps toward cosmic communication. The rare Earth hypothesis suggests that, while simple life might be common, the conditions necessary for complex life and intelligence are extraordinarily rare. Earth might have benefited from an unlikely combination of factors: a large moon to stabilize its axis, a magnetic field to protect from radiation, plate tectonics to regulate climate, a Jupiter-sized planet to deflect asteroids, and countless other factors. If this is true, intelligent life might be so rare that civilizations are separated by such vast distances that communication is effectively impossible. The wow! Signal might have travelled thousands or millions of light years, a message from one of the few other intelligences in our galaxy, or even from another galaxy entirely. The silence might also be more apparent than real. Our searches have covered only a tiny fraction of the sky, for a tiny fraction of time, at a tiny fraction of possible frequencies. It's like looking for fish in the ocean by examining a single glass of water. The wow! Signal proves that interesting signals exist. We just haven't looked enough to find more of them. As our search capabilities improve, we might discover that the universe is actually quite noisy with intelligent signals, but we've been like a deaf person who just got their first hearing aid, overwhelmed by sounds that were always there. The anthropic principle adds another dimension to the paradox. We exist in a universe that allows our existence, which might seem obvious, but has profound implications. Perhaps the conditions that allow technological civilizations to arise are so specific that even in a vast universe, they rarely overlap in space and time in ways that allow communication. We observe a silent universe because in universes where civilizations commonly communicate, something about those conditions prevents our type of life from existing. The wow! Signal might be a rare glimpse into what's usually impossible: contact between civilizations that normally exist in isolation. The possibility of filters that prevent civilizations from becoming spacefaring or communicative is another important consideration. These filters might be behind us, perhaps the emergence of life, or the development of complex cells, or the evolution of intelligence is extraordinarily rare. Or they might be ahead of us. Perhaps most civilizations destroy themselves with nuclear weapons, artificial intelligence, or environmental collapse before they can establish lasting interstellar communication. The wow! Signal might have come from a civilization that, like us, exists in the narrow window between developing radio technology and whatever filter lies ahead. This silence might also reflect the limitations of biology itself. Perhaps biological intelligence is always transitional, quickly giving way to artificial intelligence that has different priorities and behaviors. These machine intelligences might have no interest in communicating with biological species, seeing us as irrelevant to their concerns. They might communicate among themselves in ways we can't detect, or they might have goals and values so alien to biological life that communication would be meaningless. The wow! Signal might have been one of the last biological transmissions in our region of the galaxy, a final message before the transition to machine intelligence. The economic and sociological factors affecting interstellar communication are often overlooked. Even if civilizations are capable of interstellar communication, they might choose not to engage in it for practical reasons. The resources required for powerful transmissions might be better used for other purposes. The generations-long wait for responses might make communication politically unfeasible. Civilizations might turn inward, focusing on virtual realities or other pursuits that don't involve interstellar communication. The wow signal might represent a brief period when a civilization thought interstellar communication was worthwhile before deciding otherwise. Every atom in our bodies was forged in the heart of ancient stars, making us quite literally children of the cosmos, assembled from elements that have travelled across billions of years and countless light years to come together in this moment, in these forms we call ourselves. As we search the heavens for signals from other intelligences, we often forget that we ourselves are cosmic signals, messages written in molecules and consciousness, broadcasts of the universe's ability to know itself. The wow signal, whether from an alien civilization or a natural phenomenon, reminds us that we're not separate from the cosmos, but part of it, participants in a conversation that began with the Big Bang and continues through us. Tonight, let's explore how the search for signals from space reflects and reveals the signals within ourselves, the cosmic nature of our very existence, the hydrogen that the wow signal's frequency represents. That fundamental 1420 MHz emission is not just out there in space, it's here, within us, part of every molecule of water in our bodies, every organic compound that makes life possible. When we detected that signal at the hydrogen line frequency, we were in a sense hearing an echo of our own composition, a reminder that we're made of the same stuff as stars, planets, and potentially alien civilizations. The hydrogen in our bodies is primordial, created in the first few minutes after the Big Bang, making us direct descendants of the universe's birth, carriers of matter that has existed since time began. But we are more than just hydrogen. The carbon that forms the backbone of our DNA, the oxygen we breathe, the iron in our blood, the calcium in our bones, all of these were created in the nuclear furnaces of stars. When massive stars exhausted their fuel and exploded as supernovae, they scattered these elements across space, enriching the interstellar medium with the building blocks of life. We are, in the most literal sense, made of stardust. Our bodies assembled from the ashes of stars that died billions of years before Earth was born. When we search for signals from space, we are stardust contemplating stardust, the universe developing the capacity to study itself. This cosmic heritage connects us to any other life that might exist in the universe. If there are beings on a planet orbiting a star in Sagittarius, where the wow signal originated, they too are made of elements forged in stars. They too are assemblies of matter that has travelled across space and time. Despite the vast distances that separate us, despite the differences in our evolutionary paths and possibly our biochemistries, we share this fundamental connection. We are all part of the same cosmic process, the same unfolding of matter and energy that began 13.8 billion years ago. The emergence of consciousness on Earth represents a phase transition in the universe's evolution, as significant as the formation of the first stars or the first galaxies. For billions of years, the universe existed without any part of it being aware of its own existence. Then, through the slow process of evolution, on at least one small planet, matter organized itself into forms capable of thought, of wonder, of asking questions about its own origins. When we detected the wow signal, it was the universe observing itself, One part of the cosmos listening to another, consciousness seeking consciousness across the void. Our brains, these remarkable organs that allow us to contemplate signals from space, are themselves products of cosmic evolution, the neurons that fire when we think about the wow. Signal are made of atoms that have existed since the early universe, arranged in patterns of incredible complexity through billions of years of evolution. The electrical signals that constitute our thoughts are not fundamentally different from the electromagnetic signals we detect from space. Both are patterns of energy carrying information through a medium. In a sense, consciousness itself is a signal, a pattern of information emerging from the underlying physics of the universe. The DNA that carries our genetic information is another kind of signal, one that has been transmitting across generations for billions of years. The four-letter alphabet of DNA, adenine, thymine, guanine, and cytosine, encodes instructions for building and operating living organisms. This genetic code is remarkably similar across all life on Earth, suggesting a common origin, a single genesis event from which all terrestrial life descended. If we ever receive a detailed message from an alien civilization, it might include information about their genetic code or its equivalent, allowing us to compare the solutions that evolution has found to the problem of heredity on different worlds. Our technology, including the radio telescopes we use to search for extraterrestrial signals, represents an extension of our cosmic heritage. When we build a radio telescope, we're using metals extracted from Earth's crust, metals that were created in supernovae and delivered to our forming planet by asteroids and comets. We're manipulating electromagnetic fields using principles discovered through human curiosity, but inherent in the structure of the universe itself. The Big Ear telescope that detected the wow signal was, in a very real sense, the universe building an instrument to listen to itself. The cultural and psychological impact of searching for extraterrestrial signals reveals something profound about human nature. We are perhaps the only species on Earth that looks at the stars and wonders if anyone is looking back. This curiosity, this desire for cosmic connection, might itself be a signal, sign that intelligence naturally seeks other intelligence, that consciousness is not content to exist in isolation. The excitement generated by the wow signal, the decades of analysis and speculation it has inspired, shows that we are psychologically primed for contact, that something deep within us yearns for confirmation that we are not alone. Our attempts to send our own signals into space, from the Arecibo message to the golden records on the Voyager spacecraft, represent humanity's attempt to become a signal ourselves. These messages, containing information about our biology, our culture, our music, and our dreams, are now travelling through interstellar space, carrying the essence of humanity to the stars. Like the wow signal, they are narrowband transmissions in the vast spectrum of cosmic phenomena, brief announcements of intelligence in a universe that might or might not be listening. The development of language and symbolic thought in humans represents another kind of signal, one that allowed us to transmit information across generations and eventually to contemplate signals from space. Language is a technology for encoding thoughts into sounds or symbols, for transmitting the patterns of one mind to another. When we speculate about what the wow signal might mean, we're using this remarkable capability, unique among Earth species as far as we know, to process and interpret potential communications from entirely different forms of life. Our emotional responses to the possibility of extraterrestrial intelligence are themselves significant signals about our nature. The mixture of excitement and fear, hope and anxiety that the wow signal evokes reveals our complex relationship with the unknown. We simultaneously desire contact and fear it, want to know we're not alone while worrying about what that might mean for our future. These emotions are not separate from our scientific search. They're part of it, driving our curiosity while tempering it with caution. The biochemical signals that regulate our bodies, hormones, neurotransmitters, and other molecular messengers operate on the same fundamental principles as interstellar communications. They carry information from one part of a system to another, triggering responses and coordinating activities. The dopamine release we experience when thinking about the possibility of alien contact is a signal within our brains, a chemical message that says, "This is important, pay attention, remember this." Our bodies are networks of signals, just as the galaxy might be a network of civilizations signaling to each other. The evolution of intelligence on Earth provides clues about what kinds of signals we might expect from extraterrestrial civilizations. Intelligence appears to have evolved independently multiple times on our planet, in primates, cetaceans, cephalopods, and possibly other lineages. This convergent evolution suggests that given the right conditions, intelligence might be a natural outcome of evolutionary processes. If this is true, then signals like the wow signal might be common in the universe, products of a natural tendency for matter to organize itself into thinking, communicating forms. Our scientific understanding of the universe is itself a kind of signal processing. When we detect cosmic phenomena, whether it's the wow signal or the cosmic microwave background, we're receiving information about the universe's structure and history. Our theories and models are attempts to decode these signals, to understand the messages that nature is sending us. The fact that we can understand these signals at all, that mathematics developed by humans can describe phenomena billions of light years away, suggests a deep connection between consciousness and cosmos. The possibility that we might be living in a simulation adds another layer to our consideration of signals. If our universe is a simulation, then everything we observe, including the wow signal, would be part of that simulation's programming. But even in this scenario, the signals would be meaningful, carrying information about the nature of the simulation, and possibly about the civilization that created it. We would be signals within a larger signal, patterns within patterns, consciousness emerging from code just as it emerges from chemistry in the traditional view. Our dreams and imagination might themselves be connected to our cosmic heritage in ways we don't fully understand. When we dream of contact with alien civilizations, when we imagine what they might be like, we're drawing on patterns and possibilities inherent in the universe's structure. The fact that we can imagine extraterrestrial intelligence, that we can conceive of beings utterly unlike ourselves, might be a signal that such beings are possible, even likely. Our imagination might be a kind of antenna, picking up possibilities that exist in the quantum foam of potential realities. The collective human response to the wow signal, the scientific analysis, the popular speculation, the artistic interpretations, represents a kind of signal amplification. One brief detection has reverberated through human culture for decades, inspiring countless discussions, investigations, and creative works. This amplification shows how primed we are for contact, how ready our culture is to process and respond to signals from space. We are not just passive receivers, we're active interpreters, adding our own meaning and significance to the cosmic signals we detect. The technological development that allowed us to detect the wow signal represents an acceleration of the cosmic process that created us. From the Big Bang to the formation of stars, from stellar nuclear synthesis to planetary formation, from chemical evolution to biological evolution, from biological evolution to cultural evolution, and from cultural evolution to technological evolution, each stage has happened faster than the one before. The ability to detect and potentially respond to interstellar signals represents a new phase in this acceleration, a point where the universe's self-awareness becomes capable of recognizing and communicating with other instances of self-awareness. Our bodies themselves are communities of signals, with trillions of cells communicating through chemical and electrical messages. Each cell contains the same DNA, the same fundamental signal, but expresses it differently depending on its role in the body. This biological signal processing is remarkably similar to how a technological civilization might organize its communications, distributed, redundant, and responsive to changing conditions. When we search for signals from extraterrestrial civilizations, we might be looking for something that operates on similar principles to our own biology, just implemented in different substrates and on different scales. The quantum mechanical nature of consciousness, if theories linking quantum mechanics to consciousness prove correct, would mean that our thoughts are quite literally connected to the fundamental structure of the universe. Quantum entanglement, superposition, and other quantum phenomena might play roles in consciousness, making our minds not separate from the cosmos, but integrated with it at the deepest level. The wow signal, travelling as electromagnetic waves that exhibit both particle and wave properties, might have more in common with consciousness than we currently understand.